Hey everyone, welcome back. Today we're going to continue working on the 2D dynamic programming questions from the LeetCode roadmap. So in the last video, we finished off these 4 questions checkmarked off here. So today we're going to work on the next 4 questions, starting with target sum. So the first question, target sum. In this question, we're given an integer array nums and an integer target, and we want to build an expression out of nums by adding one of the symbols plus or minus before each integer in nums, and then concatenate all of these integers. So for example, if nums is 2, 1, we can add a plus before the 2 and a minus before the 1. So we get 2 minus 1, which is equal to 1. So we want to return the number of different expressions we can build, which eventually evaluates to target. So looking at the examples here, in example 1, nums is all 1s, 5 1s, and target is 3. So the output is 5, which represents there being 5 ways to assign plus or minus symbols in front of these numbers here to make the target sum be 3. So looking at the explanation, we need 3 of the 1s essentially to be pluses, but we need 4 of the 1s to be pluses and 1 of them to be a minus. So there's 5 ways because we can have the 1 be the first one, second one, third, fourth, or fifth. So these are the 5 different ways we can make a 3 given the nums of all 1s. So in example 2, a lot simpler, nums is just 1, target is 1. We need to have a plus sign in front of this 1 to make a positive number. If it's a minus, then it's not going to be equal to target. So in this question, this looks like a DP question because there's a lot of different subproblems here. So for example, if we know the sum of everything from 0 to the 4th number here, then we know the sum, which is going to be 4. Then we can look at the last number and decide whether or not to put a plus or a minus. So essentially, we can look at one number in nums at a time. So starting off with the first number, 1, we can look at the different answers or different numbers that this 1 could make. So because this 1 here, starting off, it can only be plus 1 or minus 1, then the 2 numbers we can make are going to be, let's make a comment here, minus 1 and then plus 1. So for minus 1, it's going to be one way. Let's create the different numbers we can make, 2, 3. So there's going to be one way to make negative 1 and one way to make positive 1. For every other number, there's going to be 0 ways to make them. So our DP is going to be like this. Whoops, this should be 1. This is going to be our DP array after looking at the first number in nums. So now we're introduced to the second number in nums, another 1. So using this number, we can make this number a positive 1 or a negative 1. So in this case, we're introducing a new number, negative 2 here, because now we can have one way to create this negative 2. Because there's one way to create negative 1 previously, now we make another negative 1. So there's now one way to make negative 2. So now this 1 basically branches off in 2 different directions. We can no longer create negative 1 with 2 1s. So then we're left with another way to create 0 coming from this here. So this, previously we could also create positive 1. And then if this new introduced 1 is a negative, then there's going to be another way to create 0. Essentially we can do minus 1 plus 1 or plus 1 minus 1. So that makes 2 ways to create 0 after looking at the second number. Again, 0 ways to create a positive 1, but this one could also, both 1s could also be positive, in which case we create a positive 2. So there's one way to create a positive 2. So this palindrome looking thing is our new level of DP after considering the first 2 numbers. So we can repeat this process until we consider every possible number in nums, and all we have to look at is the number of ways to make target. So DP of len nums minus 1 and target is going to create our answer. So with this out of the way, let's actually write the code. So to make our life simpler, let's create m and n. These are going to be variables to represent the len of nums. So the number of numbers in nums and target is going to be n. So let's let that be target. So now because we have negative numbers here, we want to create DP as a dictionary instead of a 2D array because arrays don't want indices to be negative, whereas in dictionaries, the indices could be negative. So DP equals to a dictionary. And we know at the start, there's going to be one way to create 0, which is by not using any number. So dp 0, 0, the first 0 represents not using any number in nums, and the second 0 means the number we're looking for, which is 0. There's going to be one way to do that. So now we want to consider every number in nums one at a time. So we can use a for loop to do that. So for I in range, we're starting from index 1 all the way to index m plus 1, because we want to include the 0th number as well, because there's one way to use 0 numbers to make 0. So the number we're dealing with is, because this is one index, it's going to be number equals to nums at I minus 1 to make it back to 0 indexed. So now we can look at all the possible numbers here. So what are the possible values that we can make up? So for j in range, let's look at the constraints here to see what the possible values are. So note that every number in nums is at most 1,000, and there's at most 20 numbers. So the range should be negative 20,000 to positive 20,000. Oh, there's another line here that says the sum of nums is guaranteed to be less than 1,000. So we can make a smaller range to make our algorithm slightly faster. So let's do from negative 1,001 all the way to 1,001. So for every number in this range, we can say dpij. This is initially going to be set to 0, and then we're going to look for the number of ways to make ij, the pair. So whenever we're looking for a number, for example, taking a look at this 1 here, initially this should be set to 0. Then we look in the row above to see, for example, there's one way to use the current number. The number is 1. So we should look 1 before and 1 after, because this 1 could be both a positive 1 or a negative 1. So we should sum the 1 before as well as 1 after. So the sum of 1 and 0, that's going to be 1. So dp at ij should be equal to 1. So we need to make sure that these are actually inside the dp dictionary, because it's possible this index doesn't exist. So if I minus 1, j minus number, this is assuming number is positive, so this is going to be j minus number coming this way. So in dp, if that's the case, dp ij, this should plus equals to dp I minus 1, j minus number. So alternatively, we can assume this number is negative. So j plus number should be in dp. So I minus 1, j plus number, if this is in dp ij, what this should be is dp increased by dp I minus 1, j plus number. So this is how we get this 1 here. It would be in the previous row, 1 less and 1 more. So we do that for every number, and we repeat this process for every row, because every row we're introducing a new number from nums to create our target. So finally, to get our answer, we can just return the one at target. So return dp, we used every number in nums, so it's going to be the last index, which is going to be m. And then target is n, so dp mn. This is going to be our answer. Let's try running it. Cool, that worked. So let's submit it. Nice, that worked. So many of these 2D DP questions, we're going to be introducing parts of arrays or parts of strings, one character or one number at a time, and then we're going to see the results. And then we're going to repeat that process until we use every single number in nums, which is going to be dp at m. And then we're going to look for what our target is, which is n. So that's going to generate our answer, and we can just return it. So let's move on to the next question. In this question, we're given strings s1, s2, and s3, and we want to find out whether s3 can be formed by interleaving s1 and s2. So by interleaving s and t, what this question means is that these two are divided into substrings, so that S is divided into substring, for example, S1, S2, all the way to Sn. T is divided into substrings T1, T2, all the way to Tm. So interleaving them means we can interweave these two parts But notice that in the interwoven string, S1 is always before S2 and T1 is always before T2. However, the rest of the order can be interchanged. Like for example, all of S could be before all of T, or they can be interwoven something like this. So A plus B is a concatenation of the strings. So looking at the example here, A, B, C, that's S1, S2 is D, B, B, C, A, and this is our target string on the bottom that we want to make. So right off the bat, we see that the target string starts with two A's. We know that S2 doesn't start with an A, so we can't use S2. That means we need to use both of the A's from S1. So these two arrows here. So now the next character is a D. S1, we're at the character B. So this is obviously not a D, so we need to use S2. However, what's interesting is that the next character here is a B. So this character is a B, and in this example, we're choosing to use S2's B. We could also use S1's B. Potentially that will work, but it could also potentially not work. So for example, if we used S1's B here, then S1's next character would be the C, which means this B, the second B, we have to use from S2. So we're done A, D, B, B, now we're on a C. We have to use the C from S1 because S1 is at the C while S2 is at the second B. So using the C here, the next character in S1 is a C, the next character in S2 is still the B. So now we can use this B from S2. Then we're left with C, A, C, so this is also a viable option. So there's more than one way we can do this. We just want to output true if it's possible, and we want to output false if it's impossible. So this question, in my opinion, is one of the more difficult 2D DP questions, mostly because it requires us to visualize a 2D matrix to be able to see how we can go one step at a time using one character from S3 at a time to determine whether or not it's possible. So starting off, to make our lives easier, let's create two variables m and n. These are going to represent the length of S1 and the length of S2. So one thing we should all note is that if the length of S1 plus the length of S2 is not equal to S3, then we always want to output false because there's no way to interleave these two strings into S3. So if m plus n is not equal to the length of S3, we can just return false right away. There's nothing else to calculate here. So now we should create a 2D DP array. One for the two dimensions, one of them is going to represent S1, the other one is going to represent S2. So we can create DP, which looks like this, 0 for nothing in range. We need to do the horizontal one first. So let's say the horizontal one, the columns is going to be S2. So n plus 1. Now for nothing in range, n plus 1. Cool, that's DP. So we did plus 1 because we always want to represent the 0th character. We could use no characters from DP S2 and use the entirety of S1 or vice versa. That's why we always want to include the 0th character in these types of DP questions. So DP 0, 0. This means that we use no characters from S1, no characters from S2. Correspondingly, we're going to get the 0th or the nothing character in S3. So there's going to be one way to do this, one representing true. So it's possible for us to create nothing if we use nothing, which makes sense. So now for every character, starting off with indices 1. So for I in range, actually we could look at not using any character in S2 first. So if we exclusively use S1, then we're always going to be working on the first column because we're going to go down the matrix. So for I in range, starting from 1 all the way to m plus 1, what we're going to do is we're going to check if the corresponding character from S1 is equal to the corresponding character in S3. Because remember, we don't care about S2 in this case. We're just filling out the very first column in our DP. So if s at I minus 1, we're doing minus 1 since this range here is going to be 1 indexed while our strings are 0 indexed. So we need to do s minus 1. So if this is equal to, s1 I minus 1 is equal to s3 I minus 1, if this is the case, dpi 0, representing the first column, is going to be equal to dp. We need to make sure the previous one is also true. So dp I minus 1, 0. Because, for example, we're looking at the third character here. Let's say we're looking at the second character, a, we need to make sure the previous one is true. So we could create the first character, and then the current character matches as well. So the second character matches as well as the previous character matching. Only in this case, then we want dp ij or I0 to be 1 in this case. So we can repeat the same process for the very first row instead of the very first column, and that means we're exclusively using characters from S2. So for j in range starting from 1 all the way to n plus 1, the same logic here. If the character in S2, j minus 1, is equal to the character in S3, j minus 1, in that case, we want to first make sure the previous one is also true. So dp 0j is equal to dp 0j minus 1. So these fill out the very first row and very first column for us to be able to use a nested double for loop to go through all the other characters remaining. So for I in range starting from 1 all the way to n plus 1, for j in range starting from 1 all the way to n plus 1. So now we're going to be at a index pair ij, and the character that we want to be comparing in S3 is going to be the, let's call that index. This is going to be I plus j minus 1. So because these two are both one index, we need to subtract 1 to make ind also one indexed. So for example, we're done filling out these two a's and the current character here. This is going to be, we're going to try to match it to the next character in S1, which is represented by the index I, or the first character in S2, which is going to be represented by the character j, the index j. So ind, we're going to have to compare ind to both of these because both of these could potentially match with it. So in the first case, it's possible we match it with the character from S1. So S1 is going to be at index I. So if the character here, S3 at ind, if this matches with the one from S1, so S1 I minus 1, because I is still one indexed, we should also make sure that we could come from S1, which means that the one before the current character, so and dp I minus 1, j is going to be true. Whoops, j. So what this means is for us to be able to use this character b, supposedly this is a b, that means the previous character, which is going to be a, has to be used. This is the dp I minus 1j is the check for that. So if both of these are true, that means we can transition from the second character to the third character in S1. In which case, the current index, so dp ij, is going to be 1. It's going to be true. So alternatively, it's also possible, for example, we're looking at this character d, then we want to match it with the character from S2. So if S3 ind, which is the current character, is equal to S2 at j minus 1, again, j is one indexed, that means we have to be able to come from this. So we have to make sure that dp I j minus 1 is equal to 1. So if this is the case, then dp I j is equal to 1. So it's possible both of these work, it's possible only one of these work, it's possible none of these work. So these are two different ways we can match the current character. And whenever we want to match the character, we need to know that the previous character in, for example, S1 must have been used. So that's why we have these two if statements here. Now after that, all we have to do is return the value at the bottom right corner of dp, which is going to be dp mn. So let's try running that. Cool. And just to get a bit more confidence in our answer, let's actually print the entirety of dp. So for row in dp, print row, just so every row is on a different line. Cool. So we know that the different rows represent the characters from S1, the different columns represent the characters from S2. So starting off using no characters from either string, we can create no characters from S3. That makes sense. So now we can use one character from the first string to make the first character in the S3, because we can't do it for S2 because S2 starts with a D, S1 starts with an A, and our goal starts with an A. That's why we're going down the rows, because we're matching them with S1. So after that, we can do the same thing for the second character, right? Because the second character is an A, and S2's second character is also an A. So this is also a 1 here. So whenever we move down in the matrix, that means we're using characters from S1. Whenever we're moving right in the matrix, we're using characters in S2. So the next character here is going to be a character from S2. We're going to have to move right because we have to use a D here. Now after that, it's going to be a B. Because B is present in both strings at the current index, we can go in both directions. We can branch off here. But this branch off eventually converges back to here. For example, we use the B in 1B here and 1B here. So 1B in S1, 1B in S2, we're going to converge. Alternatively, we can use both B's in S2, in which case we're going to travel horizontally. So there's going to be two different paths we can take, but both of these paths are eventually going to lead us to the final answer, which is going to be 1, which means true. We could create an interleaving string. So if this bottom character here is not a 1, if it's a 0, that means we should return false, and we cannot create an interleaving string. So that's the idea behind this question. This matrix is a little bit hard to draw out, so I just decided to print it from this example. I think this example is a really good one, and hopefully that makes a little bit more sense. So let's try submitting this. Cool, that worked. So moving on to the next question. Longest increasing path in a matrix. So in this question, we're given an m by n integers matrix, and we want to return the length of the longest increasing path in the matrix. So in each cell, we can move in 4 directions, move adjacently. We can't move diagonally or outside the boundary. So in this question, in example 1 here, the best path is going to be 1, 2, 6, 9. Notice that we can't start from this one on the bottom right because we have to be always strictly increasing. 1 to 1 is not strictly increasing, so that's going to not work. So some other paths, we can go 1 to 8, we can go 4 to 9, 6 to 9. All of these are going to be shorter than the length of 4, which is going to be the longest. Now we're going to be searching at the current. So in example node. 2 here, we can go 3, 4, 5, First 6. Of all, we should determine the height of the current one. But we can't actually use the 1s or 2s matrix because these are not connected to the 3. It has to be directly connected, not diagonally connected. And now matrix. So in example 1, we just have a matrix of 1. So the output is now we're going to look for the maximum height that we can go to. Cool. So this question is actually a lot easier than the previous question. This is going to be a 2D DP question because for every spot here, we're going to have to store how far we can go or the maximum increasing path is. Then whenever anything is connected to it, for example, this 6 is connected to the top 9. If we already computed that for this top 9, there's a path of length 1, as in we can't go anywhere, then we can just take the path, the maximum path leading to the 6, add it to 1, and that's going to be the length of our maximum path. So this question, first let's create m and n as usual. That's going to be the size, so len matrix, the number of rows, and len matrix 0, which is the number of columns. So we should create TP. Let's just create as a dictionary like before. And we can create a DFS function like we did in the graph questions to search the top, left, bottom, and right. So define DFS. What this is going to take in is going to take in the matrix as well. It actually doesn't have to take in the matrix because we're never going to be changing the matrix. So all we have to take in is the row and the column. So first of all, we should check if RC is in DP. If it is, then we don't have to search anymore. We can just return. So return DP RC. So suppose we never searched RC. So oops, I forgot in DP. So suppose we've never seen this row column pair before. That means we have to DFS search on this row column pair. So first, let's say the height of this is going to be a matrix at R and at C. So now we can do a DFS, as in go in all 4 directions. So let's actually create the directions first. So directions, this is going to be -1, 0 to represent going up 1. We can go down 1, 1, 0. We can go left 1, 0, -1, or we can go right 1, so 0, +1. These are the 4 directions. Now for dr, dc in directions. So dr plus equals to r to add it to our current row, dc plus equals to column. So this is the change on rows and columns. So we have to make sure this new dr and dc are not out of bounds. So if 0 is less than equal to dr less than m, and 0 is less than equal to dc less than n, as well as the next cell is strictly greater than our current cell, because we always want to move in a increasing path. So and matrix dr dc is greater than height. So if all of these are satisfied, then we're able to traverse to this one. So let's call that next dist equals to dfs, and what we're passing in is dr dc to search the next spot. So now our maximum is going to be the maximum of this, the previous maximum or next distance, and we should +1 to represent coming from the current cell. So for example, if the next distance is going to be 3, this 2 is going to yield 3 because 1, 2, 3. Then we should also include the current cell 1 to get a path of 4. So then we should return mx. Before that, I forgot to initialize mx, so mx is going to be at least 1 to represent the current cell, and we should also add it to dp. So dp rc, just to memorize it so we don't have to search it again later. This is going to be equal to max, or mx. So now it's pretty simple. We have to run this DFS function for every possible node in the entire grid to look for the optimal answer. So let's create our answer, initialize to 1. For I in range m, we're just going to search the entire grid here. So for j in range n, our answer is going to be the maximum of answer, or DFS, and what we pass in is the current column, current row, and current column, ij. So this is going to find the longest increasing path, so we can just return that one, return ans. Let's try running it. Cool, that worked. Let's submit it. Nice. So this question is pretty easy. We just have to run the search function on every single possible node and remember to memorize our results so we don't have to search them more than once. So this is mostly a DFS question. The only trick here is that we have to use a 2D DP approach to memorize our answers. So let's move on to the next question. Distinct subsequences. So in this question, we're given 2 different strings, s and t, and we want to return the number of distinct subsequences of s, which equals t. So the test cases are generated, so our answer is always inside an int. Now, looking at the example 1 here, s is a rabbit with 3 b's, t is rabbit with 2 b's. We want the number of distinct subsequences of s, which equals t. So in this case, we need 2 of the 3 b's to create our t string. So picking 2 of the 3 b's is going to get us 3 different ways, because we need to drop at least one. We need to drop exactly 1 b. So if we drop the first one, the second one, the third one, that's going to be 3 distinct subsequences, which all equal to t. So that's shown here. First, we drop the last one, or the first one, or the middle one. All of those cases is going to be rabbit with 2 b's. So in example 2 here, we're given BABG, BAG, and we want to make t, which is bag. In example, we can use the BA at the start, the first G, we can also use the second G, so the first G here, second G here, or we can just use the B and then use the AG later, or we can start off with the second B, use the later AG, or use the last B and AG. So all in all, that's going to be 5 different ways for us to generate bag from S. So this seems like a pretty challenging question, but in reality, this question is pretty simple, especially when there's a lot of characters that can be exactly matched from S to T. So whenever we have a matching, for example, R and R, these are matched, all we have to do is consider the subproblem, which is going to be the remainder of characters in S and the remainder of characters in T. So whenever there's an exact matching, we just have to look at which characters we can use in how many different ways they are to match the remaining characters. So what if there is not a matching? So for example, suppose we're given here B, B, B. This final B here is going to be matched to an I. So this is not going to be a matching, and we can only drop characters in S because we want subsequences of S. So whenever there's not a matching, then we have to skip this character in S, move on to the next character in S, which is going to be an I, and then continue the matching from there. So for example, at the last B, this doesn't match with the I, so we skip this one and then find the number of ways we can match the remainder of characters in S, which is going to be IT, and the remainder of characters in T, which is going to be IT as well. So in that case, there's going to be one way. So that's the number of ways we can match, for example, bit with IT. Essentially, there's going to be only 2 cases. There's the case where it matches, so we just do the remainder of characters in both strings. If it doesn't match, then we have to skip this character in S and then move on to the next character in S, and then match it with the remainder of characters in T. So in this question, let's first of all get the lengths. So M and N, these are going to be the lengths of S and the length of T. So we should also create a DP so we avoid searching the subproblems more than once. So for example, a subproblem would be matching everything except the R's in both strings. So DP equals to a dictionary, and we should create a DFS function, so def DFS, starting from IJ. So just like before, we just want to avoid searching this pair of IJ more than once. So if the pair IJ is in DP, we can just return DP IJ immediately. Oops. So now we should consider the end cases, which is when we finished iterating either S or T. So if we finished iterating T, that's a good thing. That means we finished using every character. We can just drop all the remainder characters in S, and there's one way to create that, which is to suppose we finished iterating T, and we still have characters in S. That means we just drop all of those, and there's one way to do that, which is dropping everything. So if the characters in T are going to be J, so if J is greater than or equal to the length of T, which is N, so that's good. We finish iterating T, we can just return 1. There's one way for us to do that. So alternatively, if we haven't reached this, but we reached the end of S, so there's no more characters in S, but we haven't finished iterating T, if I is greater than or equal to M, then we want to return 0, because there's no way for us to finish T when we have no more characters left in S, so we return 0 here. Now let's create our answer, and suppose the character, so that means we're not done S and we're not done T. So now we can compare the characters in S and T with each other. So if S at I equals to T at J, so if these two are equal, then we want to consider the remainder of characters in both strings, which means ans plus equals to DFS I plus 1, J plus 1. We're considering all the remainder characters, not the current character anymore. So alternatively, we could also not use the current character. For example, we have the B here. We don't have to use this B necessarily, and we can just skip it. So ans could also skip DFS I plus 1 and J, which means we keep the current character at T, but we skip the character at S. So notice that there's no if statement before this, because we can always have the option of skipping the current character. For example, whenever we have RA and then we hit this first B, we don't necessarily have to use it, right? Like in this test case, we don't use it. So if we don't use it, then comparing the rest of BBIT to the rest of T's BBIT by not using the first B. So, or we could not use the second B, or we could not use the third B. So this is going to generate us the 3 answers in example 1 here. So we need to make sure we memorize our answer. So dp ij, we have to store that. So this is equals to ans, and we want to return ans. So now to call our function dfs, we can return dfs, and we want to start at the first character in s and the first character in t. So it's going to be dfs 0, 0. Let's try running that. Cool, that worked. Let's submit it. Nice. So this question, it is a hard, but in reality, it's not too difficult, and the coding it up is actually very simple because there's only relatively 2 cases when comparing different characters. For example, the case where the characters are the same, R and R. Then we just move on to comparing the remaining characters, dfs I plus 1, j plus 1. Or if the characters don't line up, then we have to skip the character in S and continue looking at the current character in T. So that's this question, and that's the next 4. This is the next 4 questions in 2D DP from the LeetCode roadmap. So thank you guys so much for watching. Hope you were able to learn something, and I'll see you in the next video.